Good evening, everyone. Thank you for your patience to be here, until the last presentation. Unfortunately, not many participants are here, but still, I will continue. Okay, the title of my presentation is Evaluating the Cost and Environmental Impact, a comparative analysis of 3D printing and the traditional construction. Uh, my name is Mohammad Huzaifa Raza, and my co-authors are Dr. Svetlana and Dr. Ekaterina and Professor Zhong. So let's move toward the contents of the presentation. Generally, the 3D printing is regarded as cost-effective and environmentally friendly. But the scenario is a little bit different when we consider the whole supply chain for starting from the raw material supply to the end final construction and disposal stage. So that's why, apart from the other studies, we have considered this study starting from considering the whole supply chain for the material supply to the final construction. So the contents for this presentation would be the research background, what's the motivation for this study, research methodology, what kind of data we use, and what kind of analysis we have conducted, a case study, we have validated those our considerations using a real-time case study, and discussion of the results, and then the futuristic scenario, like what could be the whether it could be beneficial in future or not, and then the conclusion of the research. So generally, why we are moving toward 3D printing, because the traditional construction is the cost intensive and even the resource intensive. Like 40% of the natural resources are consumed by the construction sector, and nearly 40% of the GHG emissions are produced by the construction sector. So in this regard, 3D printing, they have the potential to reduce the cost, to reduce material consumption, and even the greenhouse gas emissions, it is reported in the previous studies. So what could be the benefits? What are the benefits for the 3D printing? It's the shorter supply chain, because it used to produce the self-supported layers. That's why, we don't need any type of firmware. So the formwork also has its long supply chain. For example, starting from the manufacturing of the formwork, and then the transportation, and then assembling process and disassembling process after the construction. So it's the entire supply chain for the formwork is eliminated in the 3D construction printing. So that's the clear benefit over the traditional construction. But what are the challenges that are associated with the 3D printing? That's the transportation. For example, if we have to construct a small house or small structure on the construction side, we have to move the entire setup for the 3D printing, and then we have to assemble on the construction side, and then after the construction we have to disassemble it, and then transport back into the constructor's side. So keeping in view these challenges, we have considered the entire supply chain, starting from the raw material and up to the final construction and the waste disposal phase. So in this case study, we have considered the two cases. For example, one is the traditional construction. Here you can see, traditional construction is quite smooth, like starting from one way, it has only one-way transportation. But when we consider the 3D printing, we have the two-way transportation for the equipment and the one-way transportation for the material. Why? Because as I discussed previously, we have, after the completion of the construction, so we have to move back the entire setup of the 3D printing back to the constructor's site. So this is the whole supply chain that we have considered for the comparison for both case studies. So considering the entire supply chains for both, we're going to perform the cost assessment for both methods. and the life cycle assessment. And for the life cycle assessment, what we have considered, like the production of the raw material, the transportation of the raw material, transportation of the equipment, and back to the supplier, and the amount of the energy consumed, and even the fuel consumed, any type of the equipment used during the 3D printing. Here's the 3D printed house that we have considered for as an our case study. And we also have considered the same type of house that's also built in the Germany, that has the same area and nearly the same amount of the nearly the same area, but different amount of the material is used because that method is totally different. So that's why like the material consumption is totally different. So in this one, like this is a two-story building that was constructed back in 2020. So this project was supported by the different stakeholders, design firms, and the material supplier, and even the equipment supplier, and the construction firm, and even the research institute, technical University of the Munich. So considering this one, how we collected the data we have collected, first of all, we segregated the entire supply chain into the different phases. For example, from the raw material supply, transportation, construction, and then disposal. So we have segregated each process into the several sub-process according to the existing research. And then we collected the data through the questionnaires from the like the from the operational level employees of the project. So then we have the follow-up interviews to fulfill the missing information that we needed. So here's the information. There is a small portion of the like the information, a small portion of the information that we have collected through the interviews, and some of the information that we collected from the online sources. We have provided the references because some of the like the data that's commonly available, for example, the amount of the like the power capacity of the equipment, and like the distances, it can be measured through the Google Maps. And actually we collected the data for the locations, and then we converted into the distances for the raw material supply and other. So here's the results. Like we have converted into the value stream mapping starting from the raw material supply. Here we have mentioned the input data like on in this phase, and here's the cost based value stream, and here's the environmental value stream. So this is the on the end, this is the total cost and the total environmental impact in terms of the greenhouse gas emissions. So here you can see like what are the potential processes that are contributing to the first of all, for the cost, that's the on-site construction. So what's the reason for this one? That's the like the labor used for this one. That's why like we have the significant impact in terms of the cost. But when we compare on the other side, like on the on-site construction, the environmental impact is nearly the zero. What could be the reason? The reason is because when there is a small scale construction, it's a two-story house. So when there is a small scale construction, we don't use the heavy equipment. So that's why most of the operations are like the performed manually. So that's why like the cost is quite higher. But on the other side, like the environmental impact is quite low in at the construction phase. But when we consider the raw material phase, that's the huge impact is created by the like the material used. This is the case for the traditional construction. So there is a little bit different results in terms of the 3D printing. Here you can see like the potential impacts are created by the transportation because there's a huge distances involved starting from the equipment supply and the material supply and the equipment supply. That's why like the impact and the cost is too high at the in terms of the transportation. So here we consider a futuristic scenario that whether it could be beneficial if we reduce the distances. We have seen the uh, the locations or the sites for the construction firms that are in the Germany. So these are the yellow icons for the construction sites. So it means these construction firms are available within the 100-kilometer diameter. So if we all the construction firms they have in future, maybe after 20 years later or 30 years later, if they are all adopting the 3D printing, so the equipment and the material is available within 100-kilometer range. So then what could be the scenario? So here's the scenario that we have considered. The like in the futuristic scenario, the 3D printing could potentially reduce the cost nearly the 60%. And the environmental impact, that is initially it was 106% higher as compared to the traditional construction, but it could be reduced by up to the 10%. So here's a key conclusion. We can see what could be the cost for the traditional construction is mainly caused by the material, but in terms of the 3D printing, that's the transportation is the main source. So that could be, however, this cost could be reduced by up to the 80% if we adopt the 3D printing is adopted by most of the construction firms in future. So even the environmental impact is still higher. Why it's higher? Because it was a small scale construction. When we compare it with the traditional construction, most of the operations are performed manually. So that's why the this impact could remain higher in terms of the 3D printing. But the scenario could be different in terms of the large scale construction, when the traditional construction also used to use the heavy equipment for the material supply for other purposes. So that's all. If you have any question, feel free to ask.